To understand what guiding controls are, we have to quickly go back and review what we mean by the types of motion that machines can undertake. And we've talked about two specific types of motion. We've talked about translation, which is motion in a linear form, so motion in a straight line. Whether that line is horizontal, vertical, diagonal, it's straight. And we also talked about rotation. So rotation is that turning motion. So just to remind us, we know that the symbols involved for actual motion are the actual arrow here for translation. Now, this implies translation in one direction, whereas an arrow with two arrowheads implies translation in two directions, or bidirectional translation. And then we've got our rotation, which is a turning arrow. Now again, rotation in one direction or rotation in both directions, bidirectional rotation. Now, when we have actual machines that have different components or parts that carry out these types of motion, well, we're always going to also have different components or parts of a machine whose job it is to guide or force certain parts to move in specific motions. So what I mean by that is when we have something like a guiding control is a part or an object that forces a type of motion. Okay, so if we think back to the windows in the classroom, so the windows are set here, and we know that at the base of the windows we have these kind of little lips at the top and the bottom that the windows can actually slide in. If those little ribs or lips weren't there, the window would just actually fall out. The window pane would fall out and land on somebody's head or on the table. The fact that those little ribs are there, so if we actually look at it, it's these little thin pieces of metal like this that force the actual window, which is in red here, to slide. And it's going to force it to slide in a straight line open and then in a straight line closed. Okay, so when something forces a certain motion on an object, we say that specific motion is a guiding control. So in the case of the window is forced to undertake what kind of motion? It's forced to slide basically this way, and then it's forced to slide that way. If we look at the two symbols above, what kind of motion is that? That is translation. So the answer here would be what kind of guiding is involved with the window and the window, like the window actual, what kind of guiding is involved with the window frame and the window pane. The pane is the actual piece of glass that moves back and forth and back and forth, and the frame is forcing it or guiding it to move in a translational fashion. Okay, so the scissors that I have, so any pair of scissors, if I draw, a pair of actual scissors here with the blade, and then you've got your handle here. These are awful, I know. Okay, and you've got your blade here, and that little piece of metal here, it basically forces or it guides the actual scissors to move in a rotational fashion. Okay, we're going to be looking at a lot of different examples of this. All right, so when we talk about guiding control, as soon as you see that, your mind should automatically think about the different types of motion. Guiding control forces an object to move either by translation or by rotation. So if I look at the doorknob, okay, the hole in the door that the actual knob fits through forces it to actually only be able to move in a rotationary manner. You can't slide that doorknob up and down. You can only turn it from side to side. So when we talk about guiding control on page 394 of your text, well, that's what we're actually alluding to. We're alluding to an object in a machine that forces another part to have to move in a specific way.